Well, thank you for joining us on this question. I've taken the liberty of setting it up. Reading it, it says, 2 normal fair dice are rolled, one red and the other blue, and the 2 numbers obtained are added together. Event A is that of obtaining an even number with the blue die. Event B is that of obtaining an even total. And event C is that of a total being 12. For each possible pair of events, determine whether the events are independent or not. Well, let's have a look at, firstly, highlighting where the event A, that is an even number with the blue dice. So the blue dice these are even numbers on a blue dice. Those 6 possibilities, that's a 2 on the blue, 1 on the red, or a 2 on the blue, 2 on the red, or a 2 on the blue, 3 on the red, or a 2 on the blue, 4 on the red, 2 on the blue, 5 on the red, or 2 on the blue, 6 on the red. All right, the other possibility is over here, where you get 1 on the red, 4 on the blue, 4 on the blue and 2 on the red, or you can get 3 on the red and 4 on the blue, 4 on the blue, 4 on the red, 5 on the red, 4 on the blue, and the possibility of 4 on the blue and 6 on the red. Now, there are other where the blue dice is even, and that's when the blue dice shows a 6. So the red dice could be a 1, 2, 3, 4, 5, or 6. All right, there are 12 possibilities. So what I'll do here is I'll say the probability of event A is 18 out of 36 possibilities. Because there's 36 possibilities ranging from a 1 on the blue and a 1 on the red. That's a score of 2. All the way up to a 6 on the red and a 6 on the blue. That's a score of 12. There are 36 possibilities here. Let's look at part B, probability of B, obtaining an even total. Now, even total, we can have a 1 and a 1. So I'll highlight these green. A 1 and a 1 is a score of 2. A 3 and a 1 is a score of 4. A 5 and a 1 is a score of 6. A 2 and a 2. A 4 and a 2. 6 and a 2. A 3 and a 1 is a score of 4. 3 and 3 is a score of 6. That's an even score. 5 and 3, that's 8. 2 and 4, that's 6. 4 and 4, that's 8. 6 and 4, that's 10. We could get a 1 and a 5. That's a 6. 3 and a 5, that's 8. See here, they're two odd numbers. Now, 2 even numbers, you get an even score. 4 and 6, 2 and 6, and 6 and 6. Right, so you can see that the green boxes are all the possibilities for getting an even score. So there are 18 ways of getting an even score. By the way, both of these are a probability of a half. Now, event C is that of getting being a 12. Let's highlight this blue. And there's only one way you can get a score of 12, and that's a 6 and a 6. So I will probably getting a C. There's only one way out of 36 to get a score of 12. Now, the question asks for each possible pair of events. So let's consider, first of all, events A and B. All right, then we'll consider events A and C as a pair of events. We will then consider B and C as 2 events and see if they're independent. Now, independent means if one happens, it doesn't change the probability of the other. So the probability of A will still be the probability of A even if B has happened, given B. So the probability of A equals the probability of A given B has happened. If they are equal, then A and B are independent, if that is true. So let's see if that's true. So we already know that the probability of A is a half. We've already established that. But what about the probability of A given B? Well, let's just look how many are in set B out of set B. How many are A? So out of the green, so look at all the greens. So there are 18, right? So just look at the 18 greens. Now, out of those 18 greens, how many are yellow? So let's circle these blue, all right? Well, let's just make circle them black. So out of the greens, how many are yellows? Well, that green is also yellow. Out of that green, they're yellow. Out of that green, they're yellow. That green, they're also yellow. Out of that green, they're yellow. Out of that green, it's yellow. Out of that green, it's yellow. Out of that green, it's yellow. Now, there are only 18 which are green. All right? And of set B, the number of set B is 18. So out of 18, how many are yellow? 9 of them. That means a half. So the probability of A given B is 9 out of 18, which is a half. Yes, a half equals a half. So yes, A and B are independent. That's true. All right, so we've established that A and B are independent. Yes, A and B are independent. Independent. A and B are independent. Now let's try C. Does the probability of A equal the probability of A given C? Well, we already established the probability of A is a half. Now, given C. Now, out of set C, how many are in set C? Out of set C, how many are A? How many are A? So out of set C. Now, the thing about set C is there's only one in set C. Out of that one, how many are A? So the probability of A given set C, out of that one, there's only one. It is also a set A. It's yellow. So the probability is 1 of probability of A given C. So given C, given the score is 12, what's the chance that it is, that the blue is even? Yeah, 100%. Trouble is, a half does not equal 1. So this is not equal, a half doesn't equal 1. Therefore, A and C are not independent. All right, we've established that. Now, are B and C independent? Well, does the probability of B equal the probability of B given C? Now, we've already established the probability of B is a half. All right, so let's change this to blue. We've already established that the probability of B is a half. So what's the probability of B given C? So out of C, how many are B? Out of set C, how many are B? So if C did happen, and C can only happen one way, only one. So out of that one way, how many of those are B? Yeah, B is an even score. Well, if the score is 12, what's the chance that the score is even? Yes, it is. There's one way. Yes, it is also in B. That's 100%. That's a 1. 1 out of 1. So the probability of B given C is 1 out of 1. Trouble is, a half does not equal 1. Therefore, B and C are not independent. The probabilities change. So if C does happen, It probably went from a half to 100%. Oh, I hope this has helped. Until next time, stay happy.